Hi everyone, this is Dr. Nak. Today we're going to learn about transformations of graphs. I am going to warn you ahead of time that this section is going to be pretty darn long. So hang in there and try not to watch the whole entire video in one sitting. For prep work, we don't really need to review the past material. However, it is extremely important that you memorize all of these 9 graphs given. Let's go over what we're going to learn in this section. So number 1, recognizing basic functions. Number 2, apply vertical and horizontal translations and applying reflection across the x and a y-axis, and summarize transformation of graphs. So what are the basic functions? So that's nothing but all these guys over here. Now, I sometimes call that mother graphs. So every time I said mother graphs, I'm talking about either one of these 9 graphs. So what we're about to do in this section is that we're given the mother graph, and we need to come up with an equation that maybe stretches it out, shrink it, flip it across the x-axis or flip it across the y-axis. And also we need to know how to graph those functions. All right, let's go over the basic functions to see what kind of function they are. So the first one is a linear equation. So this is given by y equals x. The next mother graph is given by y equals x squared. And the next graph is given by y equals absolute value of x. And the next graph is given by y equals square root of x. And the next one is the graph of y equals cube root of x. And the next one is given by y equals x cubed. And the next one is given by y equals 1 over x. And the next one is y equals e to the x. It's an exponential function. And the last graph right here is going to be y equals natural log of x, which we'll learn later on. And then also we'll learn about the e to the x later on as well. So now your job is to memorize all these 9 mother graphs. Let's go over what we're going to be learning first. The first topic is going to be the vertical translation of graphs. So given y equals f of x, so this will be the mother graph. So it will be one of those basic functions. Okay, now the graph of y equals f of x plus k is the graph of y equals f of x shifted k units upward. And the graph of y equals f of x minus k is the graph of, you take your mother graph and then you're going to have to shift that k units downward. After we learn that, then we're going to jump into horizontal translation of graphs. So again, given the mother graph, let h represent a positive real number. It says the graph of y equals f of x minus h is the graph of y equals f of x shifted k units to the right. And the graph of y equals f of x plus h is the graph of y equals f of x shifted h units to the left. Then, after we're comfortable with that, then we're going to jump into vertical shrinking and stretching. So again, given a mother graph, let a represent a positive real number. So here we go. If a is strictly greater than 1, then the graph of y equals a times f of x. Is the graph of y equals f of x stretched vertically by a factor of a? Now, if a is strictly in between 0 and 1, then the graph of y equals a times f of x is the graph of y equals f of x shrunk vertically by a factor of a. And next, we'll be talking about the horizontal shrinking and stretching. So again, given y equals f of x, let a represent a positive real number. It says if a is strictly greater than 1, then the graph of y equals f of ax is the graph of y equals f of x shrunk horizontally by a factor of 1 over a. And if a is strictly between 0 and 1, then the graph of y equals f of ax is the graph of y equals f of x stretched horizontally by a factor of 1 over a. And please note, for any point x comma y on the graph of y equals f of x, the point x over a comma y will be on the graph of y equals f of ax. I know, it's totally overwhelming, right? But if I were you, I will write these down. However, I did make you a summary sheet of all the translation on the next page. And the last thing we're going to be learning about the transformation is the reflections across the x and y axis. It says consider a function defined by y equals f of x. The graph of y equals negative f of x is the graph of y equals f of x reflected across the x-axis. And the graph of y equals f of negative x is the graph of y equals f of x reflected across the y-axis. Now, this portion here is just a typical guidelines how to transform your given graph, but you don't necessarily have to follow in this order. But anyways, so here is the summary of all the things that we talked about. So I have separated into horizontal shift. So horizontal shift, we're going to be talking about f of x plus h. So what do? Shift y equals f of x left h units. And then here, if you go f of x minus h, then what you need to do is you're going to have to shift that mother graph right h units. I know this is all overwhelming and all, so if I were you, I would just write this out, or you can just print this page out, just the summary portion, and then kind of keep it handy as we go through some examples. All right, I think we're ready to do this, so let's go. Our first topic is vertical translations of graphs. So consider a function defined by y equals f of x, so this will be your mother function. And it says the graph of y equals f of x plus k is the graph of y equals f of x shifted k units upward. And the graph of y equals f of x minus k is the graph of y equals f of x shifted k units downward. All right, example 1, use the translations to graph. Find the domain and the range of the resulting graph. Okay. So part A, let's go over f of x equals square root of x plus 2. So first, what we need to do is you have to determine the mother graph. So what do you think it is? I would say the mother graph is y equals square root of x. So first, let's graph this out. So we know what the square root of x graph looks like, but we need to find out some distinct key points. So in order to do that, maybe we can do that by making by x and y chart. All right, so let's pick some nice numbers here. So first of all, can we put a negative numbers in here? Is square root of negative defined over the real number system? No. So what we need to do is we have to start from 0. So let's do it. So here, when x is 0, y is square root of 0, which is 0. So we're going to be plotting the origin. Now let's go with 1. And square root of 1, we can compute that. That's 1. So we're going to be plotting 1, 1. Now, what will be the next nice number to pick? I would say 4 because we know what the square root of 4 is going to be. So next, let me just pick 4. Then the square root of 4 is 2. So we're going to be plotting 4, 2. And I think that might be good enough. So let's do it. So the mother graph is going to be 0, 0. And please make sure to write down the ordered pair there. So here, this point is 0, 0. The next one is 1, 1. So that will be here. And the next one is 4, 2. So we got 4, 2, 4, 2. And since we know the behavior of square root of x because we memorized it, so to kind of connect the dots nicely to create, oh my gosh. All right, y equals square root of x. All right, now let's look at our f of x. So what we want to graph is square root of x and then plus 2. So what do you think we need to do? Yes, we need to shift this mother graph 2 units upward. Because if I add k to it, to the mother graph, the graph of y equals f of x will be shifted k units upward. So here what you need to do is you have to take each point and then you're going to move that 2 units up. So here, let me just start out with 0, 0. So 0, 0 is going to go where then? It's going to go to 0, comma 2. And then, well, let's do it one step at a time. So let me change the color. And let's just jot this down here. So this is going to be 0, comma 2. And then 1, comma 1. Okay, so 1, comma 1, we're going to shift this point 2 units above. So you're going to go 1 and a 2. So we're going to be plotting 3, comma 1. Okay, and the last point, 4, comma 2, pretend that that blue line is crossing 4, comma 2, sorry. So here what we need to do is we have to shift this 2 units above. So you go 1 and 2. So it looks like we're gonna be plotting 4, comma 4. So let's do that. 4, comma 4. All right, now let's connect those dots. Oh gosh. It's not too bad, I guess. So this is the graph of f of x equals square root of x and then plus 2. So let's write down what we did. So given the mother graph here, right, y equals square root of x, then the next graph, which turns out to be f of x, what we wanted, but sometimes you're going to have to transform multiple times. So what I usually do is I'll just write y1, which is same thing as the square root of x and then plus 2. So I would write this as shift y, which is the mother graph, 2 units upward. Is it okay if I put a up arrow? I hope you understand that. Okay, so then we graphed out the orange curve, which is f of x equals square root of x plus 2. Next, let's determine the domain and the range. All right, so ready? So the domain is set of all x values where that function is defined. So we're trying to find the domain of this curve here, not the blue one, the orange one. Okay, so what are the where does the graph begin? Well, graph begins at x equals to 0, right? Because remember, domain is all the x values. So x is 0, and then where is it going to go? All the way down to infinity, because this tail end is going to keep going and going and going. So here, I would write the domain as closed 0 up to positive infinity. And let's do the similar thing for the range. Now the range is where the set of y values where the function is defined. So here, so here's the y values here, right? Where does the graph begin? Y equals to 2. And then remember, this tail end of the graph is going to keep going up and up and up and up, up and up, very slowly, but surely. So in this case, right, y value is going to start from 2, and eventually it's going to go towards positive infinity. So here, our range is going to be 2, comma, infinity. So that was our first example. Now let's take a look at the next one. All right, let's look at f of x equals cube root of x minus 4. So here, our mother graph is going to be y equals cube root of x. Now let's just write down what we're going to do to the mother graph. So again, I think we can do this in one step. So here, let's just call it our next function is y sub 1, which is going to be cube root of x minus 4. So what are we going to do to the mother graph? What you need to do is you're going to have to shift y 4 units downward. So I'm going to just put the down arrow here that indicates it's going to go down 4 units. All right, now I think we're ready to graph, so let's do it. All right, so now we know the cube root of x graph looks like, but we need to get distinct points. So let's make a chart. Okay, so let's see what is good here. So here, right, since we're giving cube root of x, you can plug it in negative values or positive values. So let's go in order. So now the trick is we need to pick a nice number. We don't want the decimal value here. So cube root of what is going to give us a nice number? I'm talking about the negative value. I would start out with like maybe -8, because look what's going to happen. When x is -8, our y is going to be cube root of -8, which gives -2. Okay, so the next one, what's the nice one? How about -1? That looks nice. -1, when x is -1, what's the cube root of -1? That will be -1. So first we're going to be plotting -8 comma -2. Then we'll plot -1, -1. And 0 is always the cute one, right? So 0 and cube root of 0 is 0. So again, this is going to go through the origin. And the next number I would choose is 1, because I know that the cube root of 1 is just 1. So we're going to be plotting 1, 1. And you know what? Let's go with 8, because I know that the cube root of 8 is going to be 2. So we're going to be plotting 8 comma 2. All right, let's do this. So first ordered pair is -8 comma -2. So where is that? 1, 2, 3, 4, 5, 6, 7, 8. That's -8 right here. -8, and then you're going to go -2. So that will be this point here. So this is -8 comma -2. And the next point is going to be -1 comma -1. So this is -1, this is -1. So we're going to be plotting right here. And then the origin, which is 0, 0. And the next point is, where was it? 1, 1. So we have 1 and a 1, so that's right here. And the next one is 8 comma -2. Sorry, so where is 8? 1, 2, 3, 4, 5, 6, 7, 8, comma 2, right? So that's 2. Let me just plot 8 comma 2. Does that look good? All right, so now since we know what the cube root of x graph looks like, do your best to connect those dots and try to draw a smooth graph. All right, so you know my skills, right? Oh gosh. Okay, that wasn't that bad. You should see the way I'm graphing this right now. I'm tilting my iPad so that way I can easily connect those dots with a smooth curve. Does that look good? Okay, let me put my iPad straight. Look, that wasn't too bad. Excellent. So this is the graph of, that's a mother graph, which is y equals cube root of x. So now what we need to do is take each point, and then we're going to have to shift that points 4 units downward. Okay, so let's first start out with -8 comma -2. So this point's going to go down 4 units, right? So think about it. Yes, I know it's really easy to go 1, 2, 3, and a 4 and make a dot, but which values are changing? Is the x values changing? Is the y values changing? It's the y value, isn't it? Because x is going to be same thing as -8, and then so y equals -2 is going to get changed. So how much would be this? This is -2, and then you just subtract 4. That will be -6, correct? So this point here is going to become -8 comma -6. So let's just plot where in the heck that is. So let me see. Where's -6 here? Hold on. -2, 3, 4, 5, -6. All right, so then here we're going to be plotting this point. So this is -8 comma -6. All right, and the next one you can do the same thing. So let's take a look at -1, -1. Remember, x value stays the same. Y value, you just subtract 4 from -1. So what's -1 minus 4? That's -5, isn't it? So here, what we're going to do is we're going to go down, and then we're going to be plotting -5. Sorry, -1 comma -5. And do the same thing at the origin. So the origin is going to go, so it's a 0, 0, but you're going to be subtracting 4 from the y value. So you're going to go 0 comma -4. So 0 comma negative 4 will be this point here. I'm running out of room, so let me just go like this. This is 0 comma negative 4. And the next one is, did I forget to label this? So this is 1, 1. So then you have to subtract 4 from 1. So that's going to be negative 3. So, oh gosh. Okay, I can do this. So you're going to have 1 comma negative 3. Oops. Okay. And the next point was, what was that? 8 comma 2. So again, subtract 4 from 2. So what do we get? 2 minus 4 is negative 2. So here you're going to be plotting 8 comma negative 2. Okay, now you just connect those dots and try to draw a smooth curve. Okay, let's try this again. Oh gosh. You got the idea, right? Oh my gosh. This is the best I can do. So anyways, this is the graph that what we wanted, which is f of x equals cube root of x and then minus 4. All right, now let's talk about the domain and a range. Again, we're looking at the orange graph, the final graph, to find the domain and a range. So where are all the x values? Well, I say it's from negative infinity all the way up to positive infinity, isn't it? So here, our domain is going to be set of all real numbers, which is negative infinity to infinity. Now let's talk about the range. I know that cube root of x is moving pretty slowly, but this tail end is going to keep going up and up and up and up and up, believe it or not, very slowly. So in this case, where's the y value? And then here, this tail end is going to keep going down, 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 down towards negative infinity. So remember, when you compute the range, you have to look at the graph from bottom upward. So that will be what? So starting from negative infinity, and then you're going to go all the way towards positive infinity. So it's going to be set of all real numbers again. So I'm just going to write it as negative infinity and then infinity. I remember when I was a student, I had the difficult time trying to come up with a domain and a range by looking at the graphs. So if you're not 100% sure about what the heck just happened, feel free to email me or feel free to call me or come see me. Our next topic is horizontal translations of graphs. So it says, consider a function defined by y equals f of x and let h represent a positive real number. It says the graph of y equals f of x minus h is the graph of y equals f of x shifted h units to the right. So if it's a negative in between, you shift it towards the right. All right, and the next one, it says the graph of y equals f of x plus h is the graph of y equals f of x shifted h units to the left. So again, if there is a plus in between, then you're going to be shifting the graph horizontally h units to the left. Example 2. Use transformation to graph. Find the domain and a range of the resulting graph. So let's first take a look at this. We're given g of x equals square root of x plus 3 and then plus 2. So what do you think the mother function is going to be? I would say y equals square root of x is the mother graph. Now let's write down what we're going to do. So here, let's take a look at our y sub 1 to be the square root of x plus 3. So what do we need to do here? This is precisely this case, isn't it? The second case. So if there is a plus in between, then we need to shift h units to the left. So in this case, what we need to do is you take the mother graph, and then we're going to shift that graph 3 units to the left. All right, so let me write that out. So shift y 3 units to the left. All right. Now let's take a look at the next operation here. So let me just call it y2. So the y2, it looks like square root of x plus 3, and then plus 2. What do you think we're going to do? We just learned the vertical shift, no? So what we need to do on the next step is this. You're going to have to shift y1 2 units upward. All right, so we're going to follow that procedure. Let's draw a precise graph for our mother graph. So let me just make the chart, x and then y equals square root of x. Let's just do the same thing as what we did before. So here, let me see. First of all, can we have a negative value for x? The answer is no, because you're given the square root. So you're going to have to start from 0. So let's go with when x is 0, then our y is square root of 0, which is 0. So we're going to be starting from 0, 0. All right, and then, you know what? Let me just jot this down. So this is 0, 0. All right, and then what we need to do is pick a nice number next. The 1 is good. Square root of 1 is 1, so we're going to be plotting 1, 1. So let me just make this grid 1, 1. So this is 1, 1. And then what will be the next nice number? How about x equals to 4? Square root of 4 is 2. So we're going to be plotting 4, 2. So let me see, where is that? 1, 2, 3, 4, 2. And you know what? Let's just pick one more. So let's go with when x equals to 9. Sorry, I'm going to have to write down here now. So the square root of 9 is 3. So we're going to be plotting 9, 3. Can we fit that even? Hold on one second. So we got 5, 6, 7, 8, 9. Oh, yes, barely, but we can fit that in. And 3 is here. So the 9, 3 is going to be this point here. I think that's good enough. So this is 9, 3. All right, so let me draw the mother graph. Oh gosh. Oh, pretend that's going through the dot. Here, I'll just make dot fatter. How's that? Okay, I'm sure your graph is way beautiful than mine, but you got the point. Okay, so now let's draw y sub 1. So the y sub 1 is square root of x plus 3. So what we need to do is we have to shift our mother graph 3 units to the left. So what we need to do is we have to take 0, 0 first, and then we're going to shift it 3 units to the left. So what values are changing here? Is it x values are changing or the y values? I would say x values, and the y values will stay the same. So in this case, mathematically, what you want to do is, given 0, 0, you take your x, and then you're going to subtract 3 from it. So 0, 0 is going to become negative 3, 0. Next, let's take 1, 1 and then shift this 3 units to the left. So what changes is the x values. So you take your 1 from the x values, you just basically subtract 3. So that will be what? Negative 2. So we're going to be plotting negative 2, 1. So that will be negative 2, 1 should be here. So this is negative 2, 1. And then you do the same thing to each point. So the next point is 4, 2, right? So the 4 is going to get changed. So you subtract 3 from it. That's going to become what? 1, 2. So you just plot 1, 2. So where is that? 1, 2. That will be here. Then let's take 9, 3. So again, just subtract 3 from 9. And what do you get? 6. So we're going to be plotting 6, 3. So let me just do that. 6, where is 6? 1, 2, 3, 4, 5, 6, 3. All right, looks good. Now we're going to draw a nice curve through those points. That just took me 3 tries to draw that, but whatever. So here, our purple graph is our y1, which is square root of x plus 3. And I forgot to write down the mother graph. So mother graph is y equals square root of x. All right, let's go through the final graph, which is y2. So the y2 is going to be square root of x plus 3 and then plus 2. So what we need to do is we're going to have to shift y1, which is the purple curve, 2 units above. So before you even start plotting the points, think about what values are changing. If you go upward, is the x value change? No, just the y, right? So you're going to be changing the coordinates on the y. All right, so let's do it. So first, what do we got going on here? We got negative 3, 0. So what we're going to be doing is we're just going to be changing the y value. How much? By positive 2. So here is you're going to get negative 3, 2 as your new point. So let me just do that. Negative 2. Now, negative 3, 2. Is that what I just said? Yeah. Okay, so let me just plot that. All right, now let's go with the next point. The next point was, oh goodness gracious, what was this point? This is negative 2, 1. So again, your y value is going to change. So it's going to be negative 2, 1 plus 2, which is 3. So here, let me just plot negative 2, 3. Okay, and then let's take the next point, which will be 1, 2. So keep your x the same value. You're going to be adding 2 to 2. So then you're going to get 1, 4. Let me just write that. 1, 4. There you go. Okay, so now where in the heck is our next point? Where is it? Is it 6, 3? Okay, so again, x stays the same. Just add 2 to 3 to get 5. So you're going to be plotting 6, 5. So here, 6, 5. Does that look good to you? All right, now let's connect those dots. This is the best I can do. So here is our final graph, which is y2, but let's just call that g of x. So our g of x equals square root of x plus 3 and then plus 2. All right, now let's go with the domain and a range. So again, we're just looking at our final graph, which is this orange curve here. So where does the graph begin? Let's first compute the domain, right? So you're going to have to look at the graph from left to right, and then where's the starting point for the x value? Isn't it at negative 3? When x equals negative 3, your graph is defined. So here, our domain is going to go from negative 3, and then how far is it going to go? Positive infinity. So this is going to be close bracket negative 3, positive infinity. Now let's take a look at the range. Remember, when you compute the range, you have to look at the graph bottom upward, right? So here, where does the graph begin? What's the y value where the graph begins? That's y equals to 2. Now keep in mind that this tail end is going to keep going up and up and up. So if I look at the graph from bottom upward, then it's going to start from y equals to 2, and it's eventually going to go towards infinity. So here our range is going to be close to 2. Again, these are all the y values, and then infinity. Our next topic is vertical shrinking and stretching. So let's just read this together. It says, consider a function defined by y equals f of x, and let a represent a positive real number. So number 1, if a is strictly greater than 1, then the graph of y equals a times f of x is the graph of y equals f of x stretched vertically by a factor of a. Number 2, if a is strictly between 0 and 1, then the graph of y equals a times f of x is the graph of y equals f of x shrunk vertically by a factor of a. And there are some nice things to know. So let me just write that out. It will probably help you a lot when you graph it out. So let's talk about when a is strictly greater than 1, right? If a is greater than 1, for sure, x, comma, a times y will be on the graph of y equals a times f of x. So x comma a times y is on the graph of y equals a times f of x. All right, now let's take this case here. If a is between 0 and 1, let me take this case here. So a is between 0 and 1, then for sure x over a, comma, y will be on the graph of y equals a times f of x. So this is good to know because, you can double check to see if you graphed it correctly. If x comma a times y is not on the graph of y equals a times f of x, then you know that you did something wrong. Let's take a look at example 3. It says use the graph of y equals g of x to graph the given function. So now, instead of an equation, we have a picture going on. So this graph is your mother graph, which is denoted by y equals g of x. Part A, we're going to graph y1 equals 1/2 times g of x. So here, do you see this situation going on? Our y1 is nothing but a times the g of x, where a is between 0 and a 1, which implies that we must shrink y equals g of x vertically by a factor of a. Now, who plays role of a? Yes, you are correct. 1/2 becomes your a. Now, in order to do this, since we're not giving the actual function, let's make a chart for x and then y equals g of x. So here's the chart. Now what we're going to do is this. We're going to plot all those points and then insert it into our chart. So the first point is when x is 3, our y, or I should say the g of -3 value is going to be 0. So here I'm going to write down as when x is -3, y becomes 0. And the next one, we have a -1 comma -2, so which means that when x is -1, our y value, which is the value of g of -1, becomes -2. And the next one is going to be 1 comma -2, and the last one is 3 comma 0. Now let's make a chart for x and 1/2 g of x, which we're calling that y sub 1. All right, now let's think about this. What we need to do is this, right? We need to shrink our y vertically. So which one is it? Are the x values changing or are the y values changing? So if you're going to shrink this vertically, do you see that only the y value is going to get affected by it, not the value of x? Versus, suppose we have to shrink y horizontally, then I would assume that here's my horizontal, so x value is going to change and then the y values are going to stay the same. Let me write that out. So here, our x values are going to stay the same. And only the y values are going to make some changes. Okay, so with that said, let's fill the chart. So here, let me see. X values are going to be the same. So here we're going to have still going to have -3, -1, 1, and a 3. Now let's compute the corresponding value for y. But look at it. Our y1 is 1/2 times the g of x. Where's g of x? Here are the values of g of x, isn't it? So 1/2 times g of x, what do you think we need to do? We need to multiply each of the y values by 1/2. Don't worry, I'm going to write all the steps out. So when x is negative 3, our y1 is going to be 1/2 times g of x. G of x value is 0, so this is going to be 0, which means that we're going to be plotting negative 3 comma 0. And when x is negative 1, our y value is going to be 1/2 times negative 2, which is going to be negative 1. So we're going to be plotting negative 1 comma negative 1. And the next one is when x is 1, our y value is going to be 1/2 times another negative 2. So that's going to be negative 1. So we're going to be plotting 1 comma negative 1. And when x is 3, our y value was given by 0. So you're going to have to go 1/2 times by 0, which is going to be 0. So we're going to be plotting 3 comma 0. So let's plot these points. So first one is x is negative 3, y is 0. So that's still going to be at this point right here. And the next one is negative 1 comma negative 1. So it's going to be here. And then 1 comma negative 1. So that's this point here. And then 3 comma 0. So we're back at the same point as g of x. So our blue curve is our y sub 1, which was 1/2 times the g of x. So now let's kind of step back and look at the graph, right? So remember, this was our original graph, and by multiplying that by 1/2, our result was we have to shrink the given function vertically. So do you see that right here, our blue curves kind of been like squashed down, right? So that denotes that vertical shrinkage. Let's take a look at part B. So part B, what we want is we want to graph 2 times g of x. So here, our g of x is still that same purple curve. So here, we're given a situation where y2 is of the form a times the g of x. Now, in this case, our a is going to be 2, which is strictly greater than 1. Now, do you remember what's going to happen then? Yes. It's going to, what we need to do is we need to stretch the given graph vertically by a factor of a, which is 2. So I'm going to write that out. Stretches vertically. So maybe y vertically by a factor of 2. So here what we're going to do is let's do the same thing as what we did earlier. Let's make the chart for the original graph and for the new graph. Okay, so here's the original one. What I did was I just copy and pasted from example A. Now here is going our new chart. We have a x times 2 times g of x, right? So here, what do you think it's going to change? X values or y values? Let's read it. We're going to have to stretch this given purple graph vertically by a factor of 2. So again, we need to stretch this vertically. So which values are changing? The y values, which means that our x value stays the same, but we need to change its corresponding y values. All right, so let's do it. So again, our x values are going to be the same. So we're still going to have negative 3, negative 1, 1, and 3. Now let's compute 2 times g of x. So here, we're going to multiply by 2 times what was our g of x value when x is negative 3. That's a 0. So 2 times 0, which is going to give us a 0. So we're going to be plotting negative 3, comma 0. And when x is negative 1, we're going to go 2 times negative 2, which is going to give us negative 4. So we're going to be plotting negative 1 comma negative 4. And when x is 1, we're going to get 2 times another negative 2, which is going to give us negative 4. So plot 1 comma negative 4. And when x is 3, we're going to get 2 times 0, which is going to be 0. So we got the 3 comma 0 going on again. All right, let's graph this out. So the first point is negative 3 comma 0. So again, we're going to start at the same place. And then we got negative 1 comma negative 4, negative 1 comma negative 4, and then 1 comma negative 4, and then 3 comma 0. So do you see that we vertically stretched our purple graph? So, but anyways, let me just connect those dots. And this is the graph of y sub 2, which is 2 times g of x. All right, now let's talk about horizontal shrinking and stretching of graphs. So let's read this together. It says, consider a function defined by y equals f of x. Let a represent a positive real number. All right, so number 1, if a is strictly greater than 1, then the graph of y equals f of ax is the graph of y equals f of x shrunk horizontally by a factor of 1 over a. And number 2, if a is strictly between 0 and 1, then the graph of y equals f of ax is the graph of y equals f of x stretched horizontally by a factor of 1 over a. Now, here's a very good things to know. So please note, for any point x comma y on the graph of y equals f of x, the point x over a comma y is also on the graph of y equals f of ax. Okay, so for the next example, example 4, it says use the graph of y equals g of x to graph the given function. So this graph right here is exactly the same graph as of example 3. I want you to see the difference between vertical shift and then horizontal shift. All right, so let's take a look at part A. Let's graph y sub 3 equals g of 2x. So isn't this of the case y sub 3 is g of ax? Right, where a is going to be greater than 1 because who plays the role of a? We have 2. So a is going to be 2. So in this case, what's going to happen? Shrinks horizontally by a factor of 1 over a, but a is 2, so it shrinks y horizontally by a factor of 1/2. Now, before we do anything, let's think about it a little bit. What's going to change? Our x values or our y values? Okay, so the new graph shrinks the original graph horizontally, right? So horizontally would be this way, no? So what gets affected? The x values. Let's write that out. So horizontal shift means that your x values are going to change, but our y value stays the same. Keep that in mind, and let's bring on the chart for the original graph. Okay, so here it is. Now let's make a chart for our new graph. So this will be the chart for our new graph, isn't it? Because g of 2x is precisely our y sub 3. Now, for the horizontal shrinking, we have to work it a little bit because of this reason. We just said that x values are going to change, right? So these values are going to be changing. However, these values must stay the same. So you so want to write here 0, -2, -2, 0, correct? But you cannot, because look at it. These are the values, y values of g of x. And these are the y values for g of 2x. So in order for us to create 0, -2, -2, 0, what we need to do is we have to make the argument of g as just x, not 2x. So what we want is given g of 2x, how do we make this portion just by x? Isn't it by multiplying by 1/2? And that's precisely what we need to do if we want to keep the same y value as the original one. So here, I don't know if you can read this. So what I wrote is this. To make this into x, we need to multiply by 1/2 so that we can keep the same y value of g of x. Now, I cannot just randomly multiply by 1/2 for the y values, right? If I'm going to multiply this guy by 1/2, and then do you see that I need to multiply the x values by 1/2 as well? Okay, so here is our new chart. So now what I did here again is that I wanted to make this into just the x. So I multiplied this whole thing by 1/2 to make it into g of x again. Then to be fair, I multiply the x values by 1/2. So now this way, our y values from g of x can stay as is, and we can just change our x value. So let's do it. So here, let me just write down the y values for g of x. That's 0, -2, -2, and a 0. All right, now what we're going to do is we're going to have 1/2 times x. So we're going to have to multiply each of the x values by 1/2 to get the new x values. So let's go. So here, the first one is going to be 1/2 times -3, which is going to be -3/2. Oh no, I'm running out of room. So here we need to plot -3/2 comma 0. And the next one is going to be 1/2 times -1, which is going to give us -1/2. So here we're going to plot -1/2 comma -2. And the next one is going to be 1/2 times 1, which is just 1/2. So we got 1/2 comma -2. And the last one, I'm going to try to squeeze it in here. So you got a 1/2 times by 3. So that's 3/2. That's just 3/2. Sorry. So this is going to be 3/2, comma 0. All right, now let's plot. All right, so the first point is -3/2. So that's -1 and 1/2. So that will be here, and then comma 0. So that's perfect right here. So this point here is -3/2 comma 0. And the next point is -1/2 comma -2. So that will be maybe, so here's -1/2 -2. So maybe it's right here. And the next one is 1/2 comma -2. And the next one is 1 and 1/2 comma 0. So that will be 1 and 1/2 comma 0. Let me just write down all the values here. This is 3/2 comma 0. And then this value here is going to be, what was that? -1/2 comma -2. And then this point right here is going to be 1/2 comma -2. So this is the graph of y sub 3, which is g of 2x. All right, so let's look at part B. Let's graph y sub 4 equals g of 1/2 x. Now, as you see, this is of the form g of ax. Who plays the role of a? That's 1/2, isn't it? Okay, so in this case, where a is between 0 and a 1, which means that we're going to have to take our original graph and we need to stretch horizontally by 1/a, where a is 1/2. So which means that what we need to do is take our mother graph and then we're going to stretch horizontally by 1/1/2, which is by 2. So again, we're given the horizontal stretches, so we have to work it a little bit. But let's bring on the original chart. Here's the original one. Now, before we go to the next step, let's think about it. So we're going to have a stretch horizontally. This is another horizontal shift, which means what then? X values are going to change, but the Y values must stay the same. Keep that in mind, and let's make a new chart. So here we're gonna have X and then G of 1/2 X. So again, we're going to do the similar trick as what we did in part A here. So we want to keep these values to be the same. So I want here 0, -2, -2, 0, but I cannot just write those values because here our argument is X and then we got the argument of 1/2 X. So how do we make this whole thing into just X? Isn't it just multiplying by 2? So that's exactly what we're about to do. But let me write that down. So then if I'm going to multiply this side by 2, then I better be fair and multiply the X values by 2. So let's make ourselves a new chart. All right, now we're able to copy down the values of g of x because this is no longer g of 1/2 x. So let's write that out. So this is 0, -2, -2, and a 0. Now what we're going to do next is we need to change the value of x. So here are all the value of x, but we need 2 times x. So we're going to be multiplying each of the x coordinates by 2. So here, let me just write down as 2 times, what's the first x value? -3. So that's going to be -6. So we're going to be plotting -6, 0. And the next one is going to be 2 times -1, which is -2. So plot -2, -2. And the next one is 2 times 1, which is going to be 2. So which is 2, -2. And the last one is 2 times 3, which is going to give us 6. So we're going to be plotting 6, 0. All right, let's go. So the first one is going to be -6, 0. So that will be here. All right, next one is -2, -2. So where in the heck is a -2, -2? Next one, 2, -2. And the last one is 6, 0. All right, now let's graph this out. So this is the graph of y sub 4, which was given by g of 1/2 x. Now, picture-wise, do you see what the graph looks like when it's stretched out horizontally or shrunk horizontally? So here, right, remember the purple one was the original graph, right? And the green curve that we just drew, that's stretching the given graph horizontally. And the first one we drew here, the orange one, do you see that it's shrunk horizontally? So picture-wise, that's how should they look. All right, now we're going to talk about the reflections across the x and y axis. So it says, consider a function defined by y equals f of x. The graph of y equals -f of x is the graph of y equals f of x reflected across the x-axis. And the graph of y equals f of -x is the graph of y equals f of x reflected across the y-axis. All right, let's do example 5. Use the graph of y equals g of x to graph the given function. So here, our original function y equals g of x is this purple graph. Okay, so part A, we need to compute g of -x. So that will be this case, isn't it? The graph of y equals f of -x is the graph of y equals f of x reflected across the y-axis. So basically what we were going to do is we're going to take this graph, right? And then just pretend that you're going to rotate the y-axis. So basically you're going to flip over the graph with respect to the y-axis. Now let's think about this. If I rotate the y-axis, right? Which values is going to change? X values or the y values? What do you think? I would think that the x value is going to change and the y values will stay the same. For this reason, let me just draw you a little picture. All right, so this has nothing to do with this problem, but I want you to notice something here. So this is the x-axis, y-axis, and let's just pretend that this is a point 1, 2. Now what I'm going to do is I'm going to rotate our y-axis. Then if I rotate it, do you see that we're going to get a dot or a point over here, equal distance from the y-axis. Now, what are the coordinates here? So if this is 1, 2, then here is 1, that's 2, isn't it? Now, if I rotate it about the y-axis, then what is this point? Doesn't it become -1, 2? Let me just write that. So this will be -1, 2. So what changed? Yes, the x value. So when you rotate it about the y-axis, your y value will stay the same, but the value of x changes. Now let's write that out. So going back to g of -x, what do? We need to reflect g of x about the y-axis. Now when we do that, we just talked about this, x values are going to change. And then our y values will stay the same. Okay, let's do exactly the same method as what we did earlier. So let's first make a chart for x and g of x. So the first point is given by -4 comma -2. So when x is -4, corresponding y value is -2. So let me just write that out. So here we're going to have a -4 and -2. And the next point is right here. We got -2 comma 1. So here, let me just write it as -2 comma 1. And the next one will be 0 comma -1. And what's the last point here? Okay, last point is 2 comma 4. Although our function is not defined there, do you see the open circle around it? That means that 2 comma 4 is not included. But anyway, so let me just write 2 and a 4. Next, let me write down the chart for x and g of -x. All right, now let's take a look. Remember, we have to keep the same exact y value here. But notice that, again, this is the y values of g of x, right? But here, this is g of -x. So what we need to do is we have to make this into just the g of x. So the argument of g must become just x. So how do I get rid of this negative? Yes, multiply by -1. Let me just write that out. I don't know if you can read this. So what I wrote was, to make this to x, need to multiply by -1. So now if I'm going to multiply this guy by -1, then I better be fair and multiply this guy by -1. So let's make a new chart. All right, I think we're good to go. So now what we can do is we can keep all the values of g of x from the original list. So here, let me just write this down as -2, 1, -1, and a 4. Now, for the values of -x, what we need to do is, remember, these are the values of x, but we need -x. So what we're going to do is multiply these x values by -1. All right, so ready? So that's, I'll just write down every single step. So this is going to be -x. So when y is -2, remember x, not the x was -4, isn't it? So here we're going to have a -4, which is going to be +4. So we're going to be plotting 4 comma -2. All right, and the next one is going to be negative of -2, so that's going to be +2. So we're going to be plotting 2 comma 1. And then the next one is going to be times 0, so that's 0. Okay, so what do we got? 0 comma -1. And then we're going to go negative times 2. Oh, that's -2. All right, so then here we're going to have a -2 comma 4. All right, let's plot. So first one is 4 comma -2. So that will be right here. Okay, next one is 2 comma 1. And the next one is 0 comma -1. So we're still going to have the same spot. And then the next one is -2 comma 4. All right, now connect those dots. All right, so this is the graph of y equals g of -x. Let's look at part B. So again, this is the given function y equals g of x. So let me just write it as y equals g of x. Same exact graph as the part A. Now what we need to do is this. We need to compute negative g of x. So let's do it. So first, let's just bring back the original chart. Okay, so what is negative g of x going to do to our original graph of g of x? You need to reflect the g of x about the x-axis. So let me just write that out. So this means that reflect g of x about the x-axis. so now let's think about which values are going to change. X values or the Y values? Think about it a little bit. I would say that the X values will stay the same and Y values are going to change. Take a look at this. So suppose, right, by the way, x-axis, this is the y-axis. So here's our point 1, comma 2. Let's see what's going to happen to 1, comma 2 if I rotate this about the x-axis. So then what we're going to get is we're going to get a point that's equal distance from the x-axis. Now, what are the coordinates? So if this is 1, comma 2, then this portion should be 1. And then this portion should be what then? Negative 2. So here we're going to have 1, comma, negative 2. Now can you see that our x values must stay the same and what changes are the y values? Okay, so now let's write down the new chart. Alright, so here x values are going to stay the same as the original one. So let's just write that. Here's negative 4, negative 2, 0, and a 2. Now, the right-hand side column is the negative g of x. So we don't really need to do much works because here are the values of g of x, right? Now, what if I have a negative on the front of it? All you have to do is multiply all these values by negative 1. So here, then, if I do that, then this is going to be 2, negative 1, and then 1 and negative 4. So we're going to be plotting negative 4, comma 2, negative 2, comma negative 1, 0, 1, and then 2, comma negative 4. All right, so let's plot those points. So we got negative 4, comma 2. So when x is negative 4, y is 2. Please make sure to write down the coordinates. So this is negative 4, comma 2. And next one is negative 2, comma negative 1. Oh, no. So, sorry. So this portion here is negative 2, comma negative 1. Next one is 0, comma 1. And the last one is 2, comma negative 4. Oh, but the thing is, remember, we have the open circle around 2, comma negative 4. So the reflection of that should also be an open circle. So here it is. Okay, now let's connect those dots. And this is the graph of y equals negative g of x. I know that I already posted this towards the beginning of this lecture, but here is the summary of all the transformations again. How y'all doing up to here? Are y'all doing okay? I know that this is going to be a long section, but I did warn you at the very beginning of the lecture. So hopefully you're not watching this in one sitting. Take a little breather and let's get to the next example. And please don't hate because more examples that we're going to go over, better you're going to get at. Okay? All right, we got this. So let's go. All right, example 6. Use the transformation to graph the function. So let's take a look at a couple of examples here. So the first one is f of x equals 1/3 times the absolute value of x plus 2 and then minus 1. We're about to work this step by step, but number 1, you need the mother graph. So who is going to be the mother graph? I would say absolute value of x. So let's write that out. And let's graph this. Now, when we do this, we need a precise graph. So let's make a chart again. Now, which values should we start the x values from? Do you want to do negative 3 to 3? Is that too much? Yeah, maybe that's too much. How about a negative 2 to 2? I think that's fair. All right, so what I'm going to do is I'm going to write down negative 2, negative 1, 0, 1, 2, and compute the corresponding value, which is absolute value of x. So here we're going to have an absolute of negative 2, which is 2. Absolute of negative 1 is 1. Absolute of 0 is 0. Absolute of 1 is 1. And absolute value of 2 is 2. All right. So let's plot those points. So we got negative 2, comma 2. That's here. Next one is negative 1, 1. And 0, 0 is next. And then 1, 1. And then 2, 2. So this is the graph of our y1, which is absolute value of x. Now, before we start computing, let's just summarize what kind of transformation we're going to use for each step to get to the f of x. So our first step was the mother graph, which was y1 equals absolute value of x, right? Now let's think about what's going to be the y sub 2. So let me just write down the steps so that way we can all do it the same way. So steps. So our first one was y1, which was absolute value of x. That's the mother graph. Now, next step, what I would do is this. Let me just write it as step 2. I would compute y2, which is absolute value of x plus 2. Now, do you remember what to do when we get that? So here, we're going to have a horizontal shift, but we have to shift y1 2 units to the left. Okay, so let me write that out. So we're going to have to shift y1 horizontally 2 units to left. Now let's go with step 3. So what I usually do is I do the vertical shifting at the very end. So let's go with, for the third step, let's compute 1/3 times x plus 2. Absolute of x plus 2, sorry. So here, let's go with y3 is going to be 1/3 times the absolute of x plus 2. So here, what we need to do is we have to compress y2 vertically by 1/3. So let me write that out. All right, so that's that. And then finally, step 4, we got ourselves the f of x. So our f of x is going to be 1/3 times absolute of x plus 2 and then minus 1. So what do we need to do to the graph of y sub 3? Yes, we need to shift 1 unit downward. So let's write that out. So here we're going to have to shift y3 1 unit downward. All right, now I think we're ready to do this. So let's get started. Okay, so I just copy and pasted our mother graph. Now let's go with our step 2. So the step 2 was the graph y2, which is absolute value of x plus 2. Let me copy and paste the original chart so that way we can easily compute y sub 2. Okay, so here is our original chart, and then I just wrote down what we're about to do. We need to shift y1 horizontally 2 units to the left. So which values are going to change? Again, this is the horizontal shift, right? So these guys are going to move around. So with that said, do you see that our x values are going to change, but the y values must remain the same? So let's make a new chart. So, okay, so now do you see that we're going to have to work it a little bit again because look at it. Our y values must stay the same as 2, 1, 0, 1, 2. So that's what we want here. But those are the value of absolute value of x, right? But right now we have absolute of x plus 2. So the question is, how do I get rid of that plus 2? How about subtracting by 2? If I do that, then I should just get an absolute value of x back. Now, if I'm going to subtract this side by 2, I better be fair and subtract 2 from the x as well. All right, so let me write that out. Now let's make a new chart. So for the x values, we're going to have x minus 2, And for the y value, we have to keep the same y value. That's why we converted this into absolute value of x. Now, do you see this? Do you see that this list and this list are equivalent, right? Because in order for us to keep this side by the original value, I had to subtract 2 from x. So here is our new list, but these two are identical. We just did a little algebraic manipulation to get from this list to this list. Okay, so now I'm going to keep the same y values. So here we're going to get 2, 1, 0, 1, and a 2. And then for the column for x, we need to go x minus 2. So here the value of our x. So we need to subtract 2 from each number. So the first one is going to be negative 2 minus 2, which is going to give us a negative 4. And the next one is going to be negative 1 and then minus 2, which will give us negative 3. And the next one is going to be x is 0, and then you got to subtract by 2, so that's going to give us a negative 2. And the next one is 1 minus 2, which is negative 1. And the next one is 2 minus 2, which becomes 0. All right, so now, therefore, let's just write down our final answer. So therefore, our official chart for y2 is going to look something like this. First one is going to be negative 4, 2. And then next one, negative 3, 1. And then negative 2, 0. Negative 1, 1. And then 0, 2. So the key part is this. These two lists are equivalent. What we did was we just did some algebraic manipulations to rewrite this into this. All right, so I'm just going to write this out that these two are equivalent. All right, now let's graph this out. The first one is negative 4, 2. So you got negative 4, 2. Next one is negative 3, 1. The next one is negative 2, 0. So that will be here. And then next one is negative 1 and then 1. And the last one is 0, 2. So this is our graph of y2, which is x absolute value of x plus 2. Okay, now our step 3, what we're going to do? Multiply that y2 by 1/3, right? So our y sub 3 is going to be 1/3 times the absolute of x plus 2. What's going to happen is we need to compress y2 vertically by a factor of 1/3. So again, let's think about this. If I'm going to compress this orange graph vertically by 1/3, what values are changing? Is the x value is going to change? Y value is going to change? What do you think? I would say y changes, but the x must stay the same because it's a vertical compression. So whatever the vertical part is, those are the values that's going to change. So now what we need to operate this on is the list from y sub 2. So let me bring that out. Here it is. And then let's make our new list for x and y sub 3. Oh, I forgot to write this out. So this means that the x stays the same. X values are the same. And the y values are going to change. Now, every time the x stays the same, the computation is much easier than keeping the y values to be the same. I'm not sure if you noticed that or not, but anyways, so let's go. So first, let's write down all the values of x. So we got a negative 4, negative 3, negative 2, negative 1, and 0. Now, to get the corresponding y values here, right? What we need to do is take our y2, because remember, this is y sub 2, isn't it? And then multiply that by 1/3. So here are the values of absolute of x plus 2, which is same thing as y2. So what we need to do is you have to multiply 1/3 to each term. All right, so let's go. So we're gonna have, if I multiply by 1/3, then this part is gonna be 2/3, 1/3, and then 0/3. Please note 0/3, that's a 0. And then next one is going to be 1/3 and 2/3 again. All right, now let's graph this out. So first we got -4 comma 2/3, right? So we got a -4. Now 2/3 means that you take this one interval, divide this by 3, and then you take 2 portion of it. So the 2/3 line will be like maybe right here. I don't know if you can see my arrow. So here, let me just plot the, where is it? -4 comma 2/3. So maybe over here. So, oh no, I'm running out of room like always. So this point right here is -4 comma 2/3. And the next one is -3 comma 1/3. So maybe that will be here. And next one is -2 comma 0, so it's this point here. And then -1 comma 1/3. And, oh no, keep running out of room. Okay, so this point here is -1 comma 1/3. And the last point is 0 comma 2/3. So maybe right here. All right, now let's connect those dots. And this is the graph of our y sub 3, which is 1/3 times by absolute value of x plus 2. Oh my gosh, by looking at these graphs and coordinates, maybe I shouldn't have written down the coordinates, because it almost looked like somebody just threw a bucket full of paint and then kind of landed on the piece of graphing paper. But oh my goodness, sorry. But anyways, I think we have one more step, right? So let's do it. All right, so our last step is y sub 4, which is 1/3 times absolute of x plus 2 and then -1. So basically you take your graph of y sub 3 and shift that graph 1 unit downward. So what do you think? Which values are going to change? X values or y values? I would say if you're going to shift the graph 1 unit down, then your x values will be the same, but the y values are going to be different. So let me write that out. Now again, if the y values are the changing part, then our job is much easier than the other way around. So let me just bring back the list for y sub 3. And now let's make a new chart for our y sub 4. So here we're going to have x. And then our y sub 4, which is 1/3 times the absolute of x plus 2 and then -1. Okay, so now let's just copy down the x values because they're going to stay the same. So we have -4, -3, -2, -1, and then 0. Now let's compute the corresponding y values here. So here, right, this is our y sub 3. And then you subtract 1 from it. So here are the values of y sub 3, but what we need to do now is you have to subtract 1 from each values here. So let's just do that step by step. So this portion is going to be 2/3 -1. Now this is same thing as 2/3 minus 3/3, which will give us -1/3. And then when x is -3, we're going to have 1/3 and then -1. So which is 1/3 minus 3/3. So which is -2/3. And the next one is when x is -2, we're going to have 0 minus 1. So this is going to be -1. and the next one is going to be 1/3 minus 1. So that's again, it's the same value, no? So that's same thing as negative 2/3. And then for the last one, we're gonna have to go 2/3 and then minus 1, which is the same value as when x equals to negative 4. So this is negative 1/3. Okay, so let's plot those. Okay, so I just cleaned up a little bit and rewrote the chart. Okay, so let's go. So negative 4 comma negative 1/3. So negative 4 comma negative 1/3 is maybe right here. Oh no, I'm completely running out of room. So this is negative 4, negative 1/3. Sorry. Okay, next one is negative 3 comma negative 2/3. So maybe that's right here. And then the next one is negative 2 comma negative 1. All right, and the next one is negative 1 comma negative 2/3. And the next one is 0 comma negative 1/3. Oh my gosh. Okay, so now let's try to connect those dots to get our final graph. All right, so the final graph is drawn in red, which is y sub 4 is 1/3 absolute of x plus 2 and then minus 1. Yikes, now it really looks like somebody vomited on a piece of graphing paper. If you want me to just redraw these graphs, I'll be more than happy to do so. So just please let me know if you could not follow what we just did. All right, so this is the actual graph, meaning the final graph in red. And I wrote down all the coordinates here. So this will be the graph of f of x equals 1/3 times the absolute value of x plus 2 and then minus 1. All right, so now let's try this one. We're given g of x equals square root of negative x minus 4. Let's first talk about who is going to be the mother graph. Well, I would say square root of x should work out because we are given a square root, and then we'll deal with the radicands in a minute. So let me just go like this. Let y1 equals square root of x. Now, before we start graphing, let's plan everything out. Let's just write down what our steps are going to be to draw the final graph. All right, so let's just call the mother graph as step 1. And let's go with step 2. Let's just pick our next graph and then let's call it y sub 2. Now, if I look at the original g of x, right? Okay, we got x square root of x taken care of, but then this guy starts from square root of negative x. So what I'm going to do is I'm going to take y sub 2 as the square root of negative x for this reason. Now, remember that if you have g of x, then g of negative x, do you remember what to do? You're going to have to reflect the graph about the y-axis. And then notice that if g of x is square root of x, then do you see that the g of negative x is going to give us square root of negative x? That is precisely what we have here. So here, our second step, what we're going to do is reflect y sub 1 about the y-axis. All right, now let's go with step 3. I think this might be just 3 steps here if we did it this way. So I'm going to call this y sub 3. So right now, we already have square root of negative x here. However, we need that to be minus 4. Okay, so then let me just do this. So let me just write it as square root of negative x minus 4. And do you remember this? If you're given like f of x, right? Then remember what's going to happen if I go f of x minus h. So when I change that into it, then remember, we're going to have a horizontal shift. So we need to shift the previous graph 8 units to the right because you have a negative sign in between here. Okay, so let me just write this out. So here what we're going to do is shift y sub 2 by 4 units to the right. So this is horizontal shifting. Okay, so I think we're good to go. So let's start graphing this out. All right, let's first deal with the mother graph. So let's make a chart as always. So for the mother graph, x and then our y sub 1, which is going to be the square root of x. Notice that we cannot have any negative values in square root. So our starting value for x should be from 0. So let's go with like maybe 0. And then square root of 0 is 0. So we're going to be plotting 0, 0. Now the next one, pick a nice number. So here I'm going to do 1 because I know that the square root of 1 is 1. So we're going to be plotting 1, 1. All right. And next, if I choose x equals to 2, square root of 2, we're going to get some decimal value. Square root of 3 also, but what about 4? When x is 4, do you see that the square root of 4 is going to come out nicely, which is 2. So we're going to be plotting 4, 2. And the next number should be 9 because square root of 9 gives us 3. So here we're going to have 9, 3. Okay, so let's plot these points. So first we have a 0, 0. And then the next one, what do we have? 1, 1. So that will be here. Next one is 4, 2. And then 9, 3. Okay, so since this is not the official graph, let's not plot any points here because remember how ugly it got on the previous example? So let me just draw the mother graph without writing down the coordinates. Okay, so, oh gosh, here we go again. Okay, pretend that is a nice smooth curve. So this is our mother graph, y1 equals square root of x. Now let's deal with y2, but as always, I'm running out of room here. So let's go on the next page and then I will copy and paste the graph that we just drew and the original chart. Okay, now let's go with y sub 2. So here, let me just make a chart, x, and then y sub 2 was square root of negative x. And remember what we're supposed to do. So in this case, we need to reflect y1 about the y-axis. Now you have to determine which values are going to be changing, x values or the y values. Think about it. I say that the x values are changing and y values stays the same because think about it. If I rotate this graph about the y-axis, you're going to get a mirror image on this side, right? So notice the x values are different, but what about the corresponding y values? They're exactly the same. Or if you can't figure it out right away, just draw yourself a little picture, right? So let's just go like this. Remember the 1, 2 business? So suppose this is 1, 2. Now, sorry, this is x-axis, y-axis. Now if I revolve this about the y-axis, then here's going to be your point. It's going to be an equal distance from the y-axis, and then our y values are the same, aren't they? So our y values are still going to be 2 here, but our x value is going to be negative 1. So here, our x values are going to change, and the y values stays the same, which means that we're going to have to work it a little bit. Okay, so we need to keep the same values for y. So which is I need to keep here 0, 1, 2, and a 3. Right? But that comes from square root of x, But right here, it's square root of negative x. So how do I get rid of that negative x? Is to multiply by negative 1, wasn't it? That was the trick. So if I multiply this guy by negative 1, then this side I should multiply by negative 1. Let me write that down. So here it is. Now we make an equivalent chart. However, our y value is given by 0, 1, 2, 3. Okay, so basically what we're going to be looking at is this chart now. Again, I had to make this into a square root of x because our y values must stay the same as the original one. Okay, but this is square root of negative x, so I need to get rid of that minus sign by multiplying by negative 1. And here I need to multiply by negative 1 as well. So therefore, this is the chart. Okay, so let me just call this y2 or something like that. So again, these two charts are equivalent. All right, so then let's start. So our y values are going to be 0, 1, 2, and a 3. And now here are the values of x, right? X values are 0, 1, 4, 9. But here I need to multiply that guy by negative. So here we're going to have a negative 0, which is just 0 still. So this is going to be 0. Let me just write that. And then the next one here, I have a 1. So what is negative 1? Well, I just said it's a negative 1. All right, so sorry. So this is going to be negative 1. You got the idea. So next going to be negative 4 and then negative 9. So we're going to be plotting 0, 0, negative 1, 1, negative 4, 2, and then negative 9 and a 3. All right, so let's do that in different color. So let me just box this. Let's clean up this chart a little bit before we started graphing. So the chart that we just drew, let me just convert that into a regular format. So therefore, our x and then y2 equals the square root of negative x chart officially becomes 0, 0, and then negative 1, 1, and then negative 4, 2, and then negative 9 and a 3. All right, so now let's plot points. We got 0, 0. Did this graph just get a little bit blurry? Oh my gosh, or is it just me? Oh my gosh, my eyes. Okay, and then negative 1, 1, and then negative 4, 2, and then negative 9, 3. So now let's just connect these. Oh gosh. All right, this is the best I can do, but you got the idea. So this is the graph of y sub 2, which is the square root of negative x. Okay, so what I did was I just copy and pasted the graph, and this is the chart that we just officially wrote for y sub 2. Now let's go with y sub 3. So for our y sub 3, let me just write the chart. So y sub 3 is going to be our final graph. So this portion was the square root of negative x and then minus 4. So the operation was we have to shift y sub 2 horizontally by 4 units to the right. Great. My eyes are getting worse and my handwriting is even worse now. What I just wrote, I'm so sorry. It says shift y sub 2 horizontal, but I meant to say horizontally by 4 units to the right. All right, so then let's just focus on this orange graph here, right? Now, I need to shift this horizontally, right? So what values are going to change again? I would say the x values are going to change and then y values are going to be the same. Which means that we got to work it again, but we got this. Okay, so now let's take a look. What we need to do is, remember, this chart is only for the square root of negative x, right? But we have the square root of negative x minus 4. So I need to get rid of this minus 4 because our y values for y3 must be the same as the y values from y sub 2. So what do we need to do to get rid of that minus 4 is add 4. Now if I'm going to add 4 to get rid of this 4, then I better add 4 to the x as well. Now let's write the equivalent chart. So here on the left hand side, we're going to have x plus 4. And on the right hand side, we're just going to have the square root of negative x. Alright, and the values better be 0, 1, 2, 3. Now let's change up the values for x. So here, these are our x values, but we need to add 4 to each of these numbers. So if I do that, let me just write everything out. So 0 plus 4 is 4. And then we have a negative 1 plus 4, which is 3. Negative 4 plus 4, that's going to be 0. And then negative 9 plus 4, that's going to be negative 5. Okay, so we're going to be plotting for 0, 3, 1, 0, 2, and then negative 5, 3. Before we plot those points, let's clean up the chart and rewrite it. But again, remember, these two are equivalent. Okay, so therefore, our chart for x and then y sub 3, which is the square root of negative x minus 4, it's going to be, here you're going to have a 4, 0, 3, 1, 0, 2, and then negative 5 and a 3. Now let's plot the points. So here we got, let me see, 4, 0, and then 3, 1, and then 0, 2, and then negative 5, 3. So here is our official graph. I'm so sorry. Maybe I should have used a different color instead of red, because orange and red right now to me looks kind of like the same. But anyways, let me just write down everything here. So the blue curve was our mother graph, which was square root of x. And the second graph was y sub 2, which was the square root of negative x. And then finally, our y sub 3, which is going to be our g of x, is going to be square root of negative x and then minus 4. All right, how y'all doing? Hang in there. This will be our last example. Hang in there. Okay, so example 7, it says find the equation of the graph below. So here the game is, what is this equation? So let me just write it out. So let's just call this f of x, right? So what is f of x? First, when we do this, we have to think about what was our mother graph. Now, what kind of a mother graph have shape like this? It's in V. Yes, that will be the absolute value of x, right? So I assume that the mother graph was given by absolute value of x, and we need to do some transformation to reach our goal, which is to come up with the equation of f of x. So let's write this out. So first, the mother graph, I'm going to take that as an absolute value of x. So here's the graph of y1, which is equal to absolute value of x. Now what should we do next? Well, notice that if this is the mother graph of absolute value of x, do you see that this graph right here is being flipped over? So let's start out with flipping the mother graph over with respect to the x-axis. So do you remember what to do? That procedure will be, let me just write it out, reflecting at the x-axis. What you need to do is you're going to have to multiply by negative 1 to y1. So here our y2 is going to be negative absolute value of x. Now let's graph that. So here it is. So this is the graph of y2 equals negative absolute value of x. All right, now we're looking at the pink graph that we just drew, which is right here. And then remember our goal, right? Our goal is to come up with the equation of the red curve here. So first of all, right, if I could move the center, or I should say the origin, to x equals to 3, meaning I should shift everything by 3 units so that at least the pointing part of the triangle is going to match up with the f of x that we're looking for. So next what I'm going to do is this. I'm going to shift y2 horizontally by 3 units to the right. And you know what? Let me just label this. So the first step, we reflected about the x-axis. Second, we're going to shift y2 3 units to the right. Now, what was the operation on that? I would say this. So let's just write down y sub 3. Remember, if you have a horizontal shift, you're going to have to go like this, no? So y sub 3 is going to be negative absolute value of x. And then 3 units to the right, you're going to have to go minus 3. So let's graph that out. So here, I'm going to take the 0, 0, and then I'm going to move this point 3 units to the right. So I'm going to dot it right here. So let me just do that. And next, what I'm going to do is, let's take this point here, which is negative 1 comma negative 1, and I'm going to shift that 3 units to the right. So I'm going to go 1, 2, and a 3. So this is the point that I'm going to jot down. And the next point, let's just pick this one right here. So, oops, supposed to be, this line's supposed to be going over the dot. But anyway, so this is at negative 2 comma negative 2. So we're going to move this dot 3 units to the right. So 1, 2, and a 3. So let's just dot it right there. Okay, now let's deal with the other side. So here, this point, let's move 3 units. 1, 2, 3. So it's going to be here. And then what we're going to do is we're going to take, which point was I just doing? Oh, let's do this one. You're going to go 1, 2, and a 3. So let me just jot that out. Was it right here? I thought it was right here. Okay, so now connect those dots. All right, so here is the graph of our y sub 3, which is negative absolute of x minus 3. So we're almost there, aren't we? We're almost there. So what will be our last step? So we're looking at this graph now, and we want to reach here. So what do we need to do? Do we not have to shift y3 2 units above? So let's do that. So here it is, shift y sub 3 2 units upward. Now, what is our final equation's gonna be? So if I do the vertical shift on y3, do you remember what to do? Yes, you need to add 2 to y3. So our final equation is going to be y sub 4, let's just call that f of x, is going to be negative absolute of x minus 3, and then plus 2. How's your head feeling right now? Are you all doing okay? I know that was a lot, but I also did a few examples, more than necessary probably, but again, more examples that you see, I feel that you're gonna get better at. So I'm definitely going to stop here, and I'm done torturing you for the day. So great job everyone, and I'll see you during the next lecture.